Rover G-series. The Rover G-series engine is a range of inline-4 common rail diesel engines designed and engineered by Powertrain Ltd, a sister company to MG Rover Group, and has been produced by Indian automotive multinational Sonalika Group since 2007. Description: the Rover G-series is a water-cooled and turbocharged inline 4-cylinder diesel engine with common rail injection. It is based upon the Rover L-series engine. The block is made of cast iron with an aluminium cylinder head. The engine uses an engine management system made by Siemens using common rail injection with an injection pressure of 1600 bar. It uses a turbocharger and intercooler. 8-valve and 16-valve versions of the engine are produced, differing in valvetrain and subsequent cylinder head design. It is marketed in India by Sonalika subsidiary Ikmal as the 2.0 CRD5BS Roman 4. 8-valve. The first production G-series engine was an 8-valve introduced in the 2007 Ikmal Rhino in collaboration with MG Rover and additionally used in the 2012 Chevrolet Tavernier 3. Each cylinder has one inlet and one exhaust valve in a single belt-driven overhead camshaft. 16-valve. First production 16-valve engine appeared in the 2012 Ikmal Extreme. Each cylinder is equipped with 2 inlet and exhaust valves and 2 belt-driven overhead camshafts. History: the G-series engine development work began in 2002 out of the need at MG Rover Group to replace both the common rail M47R engine in the Rover 75 and MG and the pump injector L-series engine in the Rover 25, Rover 45, MG ZR and MG CS. The engine, known as Galileo, spent 3 years in development prior to MG Rover Group's collapse in 2005. To be used across the MG Rover Group range of cars, with the exception of the TF sports car, the new engine's targets were to emulate the BMW M47R in power, torque and refinement and meet Euro 4 emissions compliance. To achieve these targets, MG Rover Group engineers introduced a new cylinder head, valves, pistons and a Siemens engine management system using a common rail system equipped with the latest injector technology available at the time to the L-series existing architecture, carrying over the cylinder block and sump. A new acoustic engine cover was designed for the engine. The throttle system was redesigned and relocated from the engine bay to the top of the throttle pedal. However, due to ongoing throttle calibration throughout development, the engine was reportedly hard to start in cold conditions. Engineers let the engine warm up before using it. According to former MG Rover Group homologation engineer Nick Vaskai, the G-series engine met its refinement target. You could park an M47 and G-series next to each other, set them idling and ask people to choose which was which, and everyone got it wrong. G-series was much quieter at idle. The G-series likewise met its performance targets. Aside from a split intercooler hose due to the amount of air being circulated at high pressure, engineers recalled that the engine performed well. In addition to being quieter to the M47R, it was engineered to replace the engine was reported to be punchy and rather frugal. By using a fully electronic variable geometry Garrett turbocharger resulting in a variation of boost pressure when installed in a Rover 75 producing 100 kW. Engineers reported that the engine was fantastic. It flew and never missed a beat whilst being driven at full chat to Sweden to sign off work on new brake control and electronic stability programs. The engine was engineered as both an 8-valve and a 16-valve unit with various power outputs. 8-valve 16-valve 60 kW 120 kW 75 kW 85 kW 100 kW. G-series engine development almost stopped following a royal decree by Kevin Hare to engineers to stop working on the engine as a former engineer recalled, MG Rover Group management stated that diesel is not the way forward. MG Rover engineers continued to work on the engine in secret despite the order. When MG Rover Group management reversed the decision and encouraged the engineering team to continue with the project due to their continued work, engineers had no real loss of engine development time. However, whilst engineers were working around the clock on the engine, it was still undergoing calibration tests as MG Rover Group entered administration in 2005. Engineers had 9 months to complete the engine calibration as soon as prototype components started to arrive at Powertrain and still needed to fully validate the engine state of June. At the time of MG Rover Group's collapse, tooling for all major components had either been completed or was in progress, with the remaining tooling being for various pieces of pipework. Following MG Rover Group's collapse in April 2005, Indian multinational automotive company Sonalika, who had been manufacturing components for the engine, bought the rights to the entire engine and have produced it since 2007. Applications: 8-valve ECMO Rhino Chevrolet Tavera Neo 3, 16-valve ECMO Rhino Extreme,